chains only bring me.
Hey guys, Mr. Rice is here with you one more time, and I'm talking today more about the chain rule. I've got two more examples about the chain rule. One that I think is kind of a classic AP problem, so we'll take a look at that. And one's got kind of a little weird simplifying, and normally I don't simplify it, but for this one I want to do a little bit of simplifying because, you know, why not? It's fun every once in a while. So here's an interesting case of what we can do with this problem here. We see an x squared here and we've got a square root. I'm actually going to do something a little tricky here, and I'm going to change this to the square root of x to the fourth times the square root of 1 minus x squared. Now I can do that because this is x squared, so positive or negative values of x, it's not going to matter because when I square root it's going to stay positive, and when I take the square it's going to stay positive. So I'm going to change this so that these two have the same power, and then I'm going to change that to the square root, and then I'm going to put it all under one square root and multiply these together. So x to the fourth minus x to the sixth. Now I'm going to use the chain rule. So I'm going to change this to x to the fourth minus x to the sixth to the 1/2 power. Right? Let's use the chain rule. Y prime equals 1/2 x to the fourth minus x to the sixth to the negative 1/2. Right? We use the power rule first. Then we derivative of the inside, which is going to be 4x cubed minus 6x to the fifth. All right, so this says just a little bit of a kind of a tricky simplifying here. What I'm going to do here is I'm going to keep all this stuff on the top. Put the 2 down here and change this. Notice that this right here with the negative square root, the negative 1/2 is just going to come down and give me a square root that I had right here in the beginning. So I'm just going to put it back to its original form. X squared square root of 1 minus x squared. Again, I don't want to lose you there. What I did was I have x to the fourth minus x to the sixth to the 1/2 power in the denominator, which is this here. And I'm just putting it back to the original form that I had, but now in the denominator. And notice I can factor the top. So I have a 2x squared I can factor out, leaves me with 2x minus 3x cubed over 2x squared, square root of 1 minus x squared, and voila, those cancel out, and I end up with 2x minus 3x cubed all over the square root of 1 minus x squared. So this is for those of you that have professors or teachers that want you to simplify. Here's some crazy simplifying for you. All right, let's look at another one that I think is kind of a classic AP exam problem. So if p of 2 is 5, q of 2 is 3, q prime of 2 is 2, p prime of 3 is 4, and q prime of 3 is 3/2, you're like, well, q prime, what are you talking about? All these primes and all these things. You'll see where we're going to use them. Find the derivative of p of q of x at x equals 2. So really we're just going to focus our attention to this. This is a chain rule, right? d dx of pq of x is simply the chain rule. So we're going to have p prime of q of x times q prime of x, right? We're just going to straight up use a chain rule right there for p and q. Now we're going to plug in our values for x equal 2. So we want p prime of q of 2 times q prime of 2. And let's go ahead and check that out. Q of 2 is 3, so really we're talking about p prime of 3, because q of 2 right here is 3. Q prime of 2 is right here, which is 2. And multiply 2. Now I'll go one more step here. P prime of 3 is 4 times 2, we get 8 is our answer. All right? So it's just a matter of making sure we use the chain rule correctly. All right there, guys. 2 more examples of chain rule. Hopefully this helps out, and you're ready to go. Catch you later.